This is a circuit with the dependent sources. We need to find the unknown currents and voltages. So anyway, this one is a voltage source, but it is a current control voltage source, a dependent source. And this one is a current source. It's a voltage controlled current source, and the voltage here is this one for the controlling voltage, and here the controlling current is this one. So yeah, I will just get rid of those things. So we'll try to write the equations, the loop equations, because we need to do loop current method for solving this one. So for loop 1, which is this one, or loop A, 60 volt, that's the voltage rise. Let's keep it over there. And then VA is the voltage drop. What can do is VA, an observation is VA is equal to 2IA. So instead of VA, I can just write 2IA. So 2IA plus this one is a drop. So 5IA minus 5IB. It has to be like that. And then this one is a voltage drop. So this one is in the same direction. So 4IB. That's the thing. So it's becoming 7IA minus IB is equal to 60. That's one equation there. Then for loop B, so this is for loop A, this is for B. Loop B again, this one going in the clockwise direction. This is a rise, so I can write it on the right hand side maybe, or maybe I will just on the right hand side. On the left hand side I am writing 0, but this one is coming as a negative. Then the drop has to be like 5IB and then minus 5IA, because the current here for this direction, since we are going clockwise direction, this is, we are assuming drop is here, but the current in this 5 ohms resistance is IB upwards and IA downwards. So for IA the voltage will be reverse, so it will be kind of a rise here, as we discussed in the loop current method, analysis of loop current method. So the third one is 4IB, because the drop will be here this way anyway. 4IB again, it's the same resistance. And this one, we don't know the voltage. What is the voltage across this one? This is a current source, so we can assume a voltage maybe Vx. So we are assuming the voltage is Vx, so we are just writing Vx. Now this one is coming to 4AB, 5AB, so this is a minus IB. This is actually this one and this one getting cancelled, sorry, this one and this one. So this one was 4IB, so this is becoming 5IA minus 5IB is equal to Vx. So I've just rearranged it. So I've taken this on the right hand side, left hand side, and this. And so this is the other equation we have now. Now for the third loop, we notice something. The third loop does not have anything else, and basically this one, the only drop is here. If we assume this is, let's say we are going in the clockwise direction and we have assumed the drop to be Vx, just the Vx is 0. So basically what we get from here, because this point and this point, they are actually short circuited, so the voltage will be 0. There will be a current because this is a current source here, voltage control current source. The voltage is of another across another resistor, which is this one. So basically Vx is 0, and that makes everything simpler. So what we can do now is, this is our third equation. So going back to second equation, which is this one, Vx is 0. So what we get from second one is Ia is equal to Ib. That's what we get here. One mistake has been done though. I will just rectify it right away. No, not that, because we don't need IC here, because there is no resistance in this branch, in this particular branch. This branch there is no resistance, so we didn't need IC actually, because if there was a resistance we had to calculate IC. The current would be that resistance times IB minus IC, and for the third one also there. So IC is we don't have the equation, in the equation it doesn't come anyway. So what we get now is IA is equal to IB. Since IA is equal to IB, we can use this equation to solve both for IA and IB. And once we find them, IA, VA is equal to twice of IB, and that way we are finding everything. And then here we also find what is the current here in this current source. We find IB as well, and that from that relation we can find what is IC, because IC there will be a current. It's a short circuit, so there will be a current flow. So basically IC will be, IB will be our node KCL equation at this node can be IB is equal to 2VA plus IC, and 2VA is 4IA. So 4IA plus IC is this thing. So since we know that IA is equal to IB, we can say IA is equal to, so basically it's becoming, IC is becoming negative 3IA. So or IA or IB, whatever, both of them. So this is how we can find IC as well. So we can find all the unknown currents and voltages by this method. So basically the purpose of doing this problem was how to use current control or voltage control current source and the sources, so the dependent sources basically, in a normal loop analysis. So I have summed up the solutions here. The equation was 7A minus IB, which is here. So since IA is equal to IB, we can solve it. So 7A minus IA, 6A is equal to 60, which gives IA is 10 amps. So IB is also 10 amps, and then VA is 2IA, so that's actually 20 volts. So if we look back, go back to the circuit, this one is a 20 volt, the drop here, and this is a 60 volts here. So and the drop at 5 volt will be 0 because IA is going downwards while IB is going upwards here. So the current is actually 0 because they are equal and opposite. So there is no current in this branch, in this whole branch. So all the current is coming here, which is IB here, which is 10 amps here. So this will also be 10 amps. There is no, at this node, no current is going downwards. And then at this node, so looking back here, this source, it is current is 2VA, and this is 40 ohms. 2VA is 40, VA is 20, so 2VA is 40. So 10 is coming this way, and we know that IC is 30. IC is actually negative of IB, so that's actually negative of 3IB. So that's actually 30 here, and since it's negative, IC was originally downwards or clockwise, it will be actually counterclockwise, so it will go towards this node like that. So this is 30, this is 10 here. So when we add up, we actually 10 ohms, 40 ampere is going down. So that's actually, it's satisfied, everything is looks fine. There is no drop in this branch. So basically this is a short circuit, but this is a current source, so it is maintaining it. That's the definition of current source, that it maintains that certain current through its through that terminals, through it, or rather, but the voltage depends on what is connected to it, so voltage can be 0 as well. So this is 0, and if we look at KVL here in the first loop, this is 60 here, 20 here, and 40 here, so that's actually 60. So 60 rise, 60 for 20 drop, and 40 drop, so that's 60. Even in this branch, this is 40 rise here, and this one is a 4 ohms, so 4 ohms, and the current is 10. So again, rise 40 and drop 40 here, so KVL is satisfied in second branch as well, and no drop here, and this is virtually a short circuit, these two. So that's all. Yes.